In this video, I'll be discussing the memory expansion board. The ROM-RAM memory expansion card is similar in design to the one that I had talked about in previous videos. That version had a MC14017 decade counter, a slightly upgraded but compatible version of the 4017, and basically this chip did the chip selection, and there was a 74HCT573 octal D-latch, and that provided the extra extra address lines, which allowed us to have a much higher capacity ROM and RAM chips. This was a little excessive, I suppose. In this version, we completely removed the MC14017 because it's pretty much considered obsolete. I did find some 4017s on DigiKey, but they're not offering very much of them. Anyway, so I wanted to aim to keep this as simple as possible while using as much off-the-shelf parts that you could get anywhere. There is up to 8 chips selectable by the expansion card's logic, and support for sizes up to 512 kilobytes per chip, given a total of 4 megabytes for the entire expansion. Each chip can be either ROM or RAM. They don't need to all be exactly the same type or size, so you can mix and match ROM and RAM. They just need to match the supported pinouts for the devices. Underneath each chip socket, at least for the DIPs, there is a set of jumpers for each chip, so you can select between the ROM and the RAM pinout, as they have very slight differences between them. Each of these memory chips will occupy a single bank, so it will be given a 16K window in which to operate, so therefore each of these chips can be considered as a set of 16K blocks. I will go into more detail about this subject later on in this video. The card is designed around the 74HCT573 octal D-latch, in a similar way from the older version, except now we store the chip selection in the top 3 bits of the 74HCT573, which is our memory expansion register. The remaining 5 bits are used as our expanded address bus, or as the block selection. The 3 chip select bits are now taken and fed into a 74HCT138, which is a 3 to 8 decoder. This will decode that 3-bit number and select the appropriate chip. The 5 expanded address bits are taken and connected to the A14 to A18 lines of the expansion memory on the card. These lines are referred to as XA14 to XA18 on the schematic and other documentation to signify that they are completely separate from the M62's address lines. So A14 and A15 on the M62 does not connect to XA14 and XA15, as this would interfere with the overall bank selection. XA14 to XA18 allowed a selection of a maximum of 32 blocks of 16K for a 512K byte chip. We simply need to load these expanded address lines with the block numbers we wish to access. We control the chip selection and block number by writing to the expansion register, which is the 74HCT573 on the card. This is done using the out instruction. There is a jumper on the card allowing a selection of its address in the IO range of hex C0 to hex C7. The byte to be written will consist of the 5 least significant bits being the block number, and the top 3 most significant bits as the chip selection, as previously discussed in the hardware. The current value of this register can be retrieved just simply by using the in instruction to the same address. The byte written can be calculated by multiplying the chip number, which is in the range from 0 to 7, by hex 20. We then add the number of the block we wish to access. Once this byte has been written, the selected chip and block will immediately be available in Bank 2, which occupies the address 8000 to BFFF in hex. The expansion card that I'm currently using does have a few flaws, and there will be some changes made for the next revision. I had trouble fitting the 8 memory chips on the same board as the logic within the 10 by 10 cm space, so I opted to have 4 memory chips on a board and use them in pairs, and then we'd have a cable that connects from one board to the other to take over the chip select lines for the top 4 chips, and basically the second card you would just not populate the logic. Unfortunately, I forgot to include the X14 to X18 lines, so basically you wouldn't be able to select anything past block 0 on the extra 4 chips. Sure, we can mod this with some wires. The next revision will include this fix. It shouldn't be a problem. In the time since this board was fabricated, I began working and designing my own operating system. It's aptly named the M62 OS. I will be doing a video about this eventually. This led me to make some design changes for the expansion card going forward. The current revision of the card that I'm using has jumpers on it to select whether we're using bank 2 or bank 3 as a 16K window, or use bank 2 and 3 as a 32K window. And this is not going to be used in the newer revisions, which is why I haven't really spoke about it in this video so far. I'm going to be fixing it to bank 2 because this will be dedicated for the expansion memory. My idea is to reserve bank 3 for video memory for a future video card, which I would eventually like to complete. The M62 OS has a dedicated space for applications, which is a little under 16K, which means we can store an entire application in a block of the ROM. Since we don't need the full 16K, this will allow a header to be stored at the beginning of each block, which leads me to consider creating a crude file system. This is when I decided to create ROMFS. ROMFS is a file system I'm currently working on as part of the M62 OS to allow applications and data to be stored in blocks of ROM and RAM. It's currently in very early development, so there's not too much to say about it right now. I felt that the overheads of the fat file systems would be a little too much for ROM storage, so opted away from that. But I haven't given up with the FATs. Basically, I'll be implementing that for compact flash cards and floppy disks as we go down the line. Okay, demo time. Okay, as you can see on the screen, I have the M62 loaded up, currently in BIOS version 1.2.3. I've not really updated the BIOS very much since I've been working on the OS. Basically now I just use the BIOS to load the OS into the memory and then jump from it. But this is not a demo for the OS, so I will show you that another time. Okay, so let's have a look. We're going to go into the monitor, and we're going to have a look at some I/O commands here. Now, my expansion card is set at C0 right now in hex, so that's where I'll be reading and writing from. I currently have 4 memory chips in the card. I'm only using a single card right now. I have 2 ROM chips in there, and I have 2 RAM chips in there. Now, I'm trying to think now. The first ROM is, I believe, 128K. The second ROM is 512K, and both of the RAM are 512K. Okay. Just make sure I got my notes with my addresses on it. Yeah, this isn't visible. There we go. Okay, so let's have a look now. So, when you start up, the card needs to be, well, I'd say initialized, but the thing is, the register on the card may have a random value in it. So I will I'll read the value of that, see what's going on. FF, that's what's currently set in there. So if I output what do I do? So C0, and I output 0 to it, and I'm going to make sure it's reading back correctly. Yeah, there we go. So right now it is selected as the first chip and the first block. So if I do a dump of the address 8000, it says ROM 0 because that's what I programmed in the ROM. But if I wanted to select the second ROM, then I do an out command to C0, that is 20. So let's dump 8000, and this ROM, I did burn ROM 1 in it. So now if I wanted to go to the first RAM, in this case it would be chip number 3, actually chip 2 because we're starting at 0, and 2 times 20 hex is 40 hex, and obviously we want the first block, so we're going to out to C0 and we want 40, and if I dump that address you're going to get gibberish because it's uninitialized. And let's see, so we can zero it out. So that's 7 F, there we go, and there we go. So we zeroed out that memory address. So let's switch to a different block for this chip. So basically we'll be outing, so I'm going to put 41 or 41 hex, which means it'll be the third chip, chip 2, and it'll be block 1, so 41. So if we dump that address, you can see it's gibberish in the second block. So let's switch the original block back in, and you can see all that's back there again. So let's go back to the original ROM. Oh, that's wrong address. Okay, so there. So we can switch backwards and forwards. I can't remember if I wrote anything on block 1 for the ROM, but let's find out. Oh, sorry. There we go. No, I didn't write anything in block 1. Well, that's basically how you'd be accessing the memory with the input and outputs. Obviously, people won't be doing this manually directly. The OS should be taking care of this for everyone. But that's the quick demo, and that's how it works. So that's the current revision of the expansion card explained. I hope you enjoyed this video. Hopefully I will get my webcam working for next time. And I would like to give a shout out and a thank to my Patreon, Zeddy. Many thanks for all your support. And I hope you're enjoying the videos, and I'm very sorry that it's been a while since I've been putting videos out. And I'll be getting some more out more often. So, thank you for watching, and I'll see you again next time. Goodbye.